Alright, so this is part 2 of adding vectors. Before I begin with the example, I'm going to show you guys a little bit about trigonometry, a right triangle specifically, because that's what we work with in physics and in trig. And you need to know this in order to solve the following problems. That's why I'm going to go over it, just in case you don't know. So this is a right triangle, and the triangle has three sides. This side right here is the x component of a vector, and it's this side is one of the legs of the triangle. This side over here is another leg, and this side is the longest length of the triangle, and this is called the hypotenuse. The hypotenuse is always going to be across the 90 degrees. So if you find this little 90-degree box, the one right across it is always the hypotenuse, and it's the longest side of the triangle. Now in physics, they're going to give you a vector, and the vector is always going to be this slanted line. It's always going to be the hypotenuse. So what you need to do with that vector is find its x component and its y components. And the reason you need this is because, remember from the other video, I told you that vectors cannot be added when they look like this, when they're slanted. Vectors can only be added when they are in this position in the horizontal x direction, or in the going up and down y direction. That's the only way vectors can be added. Okay, so they're going to give you an angle in addition to the length of the vector. They tell you the magnitude of the vector, which is the length, and they give you an angle. And to find the x and the y component, you need to use trigonometry. You need to use something called sine, cosine, and tangent. This angle is called theta, and if you want to find, let's say, the y component of the vector, you're going to use sine. Sine of theta, or sine of that angle, is equal to the opposite side over the hypotenuse. The opposite side of this angle right here is this, the y, and the hypotenuse would be whatever measurement they gave you over here. So you use sine of theta in this case to find the y, and if you want to find the x, you're going to use the cosine of theta, which is equal to the adjacent side over the hypotenuse. So if this is the angle, the adjacent is always the one that's right next to it. So it's going to be, in this case, the x, and the hypotenuse, whatever, again, they give you. That's how you find the x. Tangent, on the other hand, is used to find the angle, because tangent of theta is equal to the opposite, which is the y, over the adjacent, which is the x. So another way to write tangent is equal to y over x. This is another way to write tangent. And tangent is used to find the angle. Remember that a vector is not just the magnitude, we also need the angle, or the direction. So now with an example, let's go to this graph over here. Okay, so I already specified north, east, west, and south, and you know that up is positive, down is negative, to the right is positive, and to the left is negative. And here's our vector. Okay, let's pretend that this is a sailboat traveling at 5 meters per second at an angle of 30 degrees, going north of east, or above the horizontal. This is the horizontal, so that's 30 degrees above the horizontal, or 30 degrees north of east, so going north of the east. In order to solve this problem, you need to find the components of the vector. Okay, and the components is always the x and the y direction. So I'm going to go to this graph, and I'm going to show you how to do that. Okay, so I'm going to draw that vector again. Here's the vector. This is 5, and this is 30. So like I said, they're always going to give you the magnitude of the vector. In this case, this is 5 meters per second. They gave you the magnitude, and they're always going to give you the direction, and then you need to find the components. So I'm going to find the x component, which is this right here. This is my x component, and the y component, which is this right here. Remember that if the head of the pink vector, that's the head, then the green vector, that's the tail of it. So this is the y, and this is the x. We're going to need trigonometry to figure out first those sides. So let's see. First, let's start with the sine. Sine of theta is equal to the opposite side over the hypotenuse. Okay, so what is theta? Theta is the degrees, or the angle. The angle in this case we said was 30 degrees, so I'm going to put here 30 degrees is equal to the side opposite. The side opposite, if you could let's look at the graph, the side opposite of 30 is y, right? So that's what we're looking for. We're looking for the y. And the hypotenuse, we said the sailboat was traveling at 5 meters per second. So to solve this problem, I move the 5 over to the other side and I write 5 sine of 30 degrees is equal to y. Okay, so now all we need to do is solve for y. And I'm going to do that with the calculator. Alright, so let's see. We have sine of 30 degrees. Make sure the calculator is in degree modes. If it's not in degree modes and it's in radians, you have to put the little degree symbol up here. So 5 sine of 30 is 2.5. So 2.5 meters per second. And the y, we already found the y. Okay, so now I'm going to find the x component. And to find the x component, I'm going to use cosine. Cosine of theta is equal to the adjacent side over the hypotenuse, if you remember from our formulas. Okay, so cosine of, again, 30 degrees, because that's the angle that I give you, is equal to the adjacent side, and the adjacent side from the diagram, let me show you. Alright, you see the diagram, the adjacent side is the x. Adjacent is the one that's right next to the 30 degrees. So that's the x. And we know that the hypotenuse is 5 meters per second. Okay, so again, I'm going to move the 5 over to the other side. So I'm going to say 5 cosine of 30 is equal to the x. And now I'm going to use the calculator to solve this. 5 cosine of 30 degrees is equal to 4.33. So the x, 4.33, is equal to the, oh, and this is in meters per second, 4.33 meters per second is equal to the x. So right now we just found the x and y component of this vector over here. So we know that the x and the y. The y is 2.5, the x is 4.33. Alright, so now that we have that, I'm going to show you another thing to this problem. This is the sailboat traveling at 5 meters per second, and up here we have a wind, and the wind is traveling at 2 meters per second to the left. Okay, it's going west. So what's going to happen is that the wind is going to slow down the speed of this boat, and I'm going to start like 9 minutes. In the next video I'm going to continue this problem.